Alright, so, the next thing that we're going to talk about are kind of a special case for confidence intervals for a difference in mean, or a mean difference. Okay? So, here. Paired data arises when we have two performances for each athlete or athletes in a group, or two performances for each team in a group of teams. Okay? One example that we started off looking at with paired data is when we were looking at the swimmers, whether they're new swimsuits, they can swim faster than their old swimsuits.
And the strippers?
So basically, what?
Mm-hmm.
So we used that data and we paired it together to find the mean difference. Because we are interested in using the mean of a single set of data, or the differences, to create an interval of plausible values for the difference in the ability, we are going to have another formula, okay? It is very, very, very similar to the formula from yesterday. Bless you. This new formula that will help us calculate the 95% confidence interval is X bar with the little d in the subscript plus or minus 2 multiplied by S with the little subscript d over the square root of n with a little d. Okay? This is the exact same formula from yesterday.
Not the little d.
The difference being the little d means you are using mean difference as your data and not just the data itself. So all this little d right here represents is your paired data. Yesterday we did unpaired, today we're doing paired data. Okay? So it's the exact same formula. I will provide the formula. I will not provide what each letter means. Yes. I will provide these three formulas. No, I will not provide the standard deviation formula. So, just the ones that we just the last three that we
Well, how come you
Which of the symbols represents the mean? Which one represents the observed mean difference? Oh, I'm sorry, I messed up. That's here. Sorry.
Dirty, bro. I've never taken it out of the case.
That's a little d. It's just not little. This one, remember the little N symbol or a cursive R? That's the mean. It's mean. To me, it looks like a little cursive M.
Where is it in
Wait, what is that?
Is that not
It's not in the formula. It's just you need to know it.
So that, okay. Is it M or R?
It doesn't matter what it is.
It's called mu. It's neither one. It's just mu. But to me, it looks like a cursive M. Someone else said it looks like a cursive R. You just have your pencil. You go up like that.
It's a half M.
It's basically an M, but you stop your line right there.
Okay.
The observed standard deviation is the S plus D. And the observed number of differences is N with a little d. Well, it's probably just going to be S, but instead of writing out standard deviation, I was just looking at it. Standard deviation can also use a symbol like that. That's another symbol that you can see standard deviation.
I thought.
Does uniform color make a difference? Okay? There was this experiment that these researchers wanted to find out if the color of the uniform really makes a difference with referees and stuff. And so what they did was they took Taekwondo and they had two people wear two different colors. One person wore red, one person wore blue. And the red, the researchers wanted to know, does red mean that, are the referees more likely to give points to people who wear red in a combat sport? Because red is kind of seen to be dominant, aggressive, anger. So would referees be biased to give more points to the red team if they wore red? So that's what this research suggested. Also, other studies concluded that difference in uniform colors can also affect the data or create a difference in the components of visibility. So, like, if I'm pitching a softball and the softball is yellow, and I wore a yellow shirt compared to like a black shirt, would it be harder to see the ball? It'd be hard for the other team to see the ball coming out of a yellow uniform than it would be if it was black.
Yeah.
So that's also. In the article, when the referee sees red, the author suggests that the positive impact of wearing red in combat sports was due to the bias of referees. To investigate, they conducted a clever experiment where they showed brief excerpts from Taekwondo matches to trained referees. So these aren't new referees. These are referees that's been scoring the sport for a while. In each split, the referee saw one participant wearing red protective gear and above their white uniform, and the other participant wore blue protective gear above the white uniform. At the end of the clip, each referee indicated how many points should be awarded to the participant wearing the red, and how many points should be awarded to the participant wearing the blue. Okay? So this is how the experiment worked. Each referee viewed 2 blocks of 11 clips. And what they did was, in the clips, they used the same clip both times, but stand up for a second. Just so we explain this pretty good. Okay, so if me and Connor are like fighting each other, which we're not going to, and Connor kicks me, and he's wearing the red uniform.
Really loud.
I'm not. Okay. It'll be okay. So Connor kicks me, and he's wearing the red uniform, I'm wearing the blue one. Well, when they randomize the clip, all they do is they take Connor and change his red to his blue using the exact same kit. Does that make sense?
No.
So it's literally they're playing the same video over and over and over again, but they just keep switching the colors. So they're not really the same.
It's the same clip, but in one clip I'm red and the other
Other
one
one you're blue. But you're doing the same move over and over and over again. Okay? So that's how this experiment worked. So once they did that, they had the referees to score both videos. So they wanted to see what was biased, what was not. So when they scored both videos, they wanted it to, so if the referees are unbiased and consistent of rewarding their points, they should have given each color the same amount of points. That was the point of that. So you watch the same video over and over, but with just different colors on both people, and at the end of all of the clips, everyone should have had the same amount of points. Well, but of course, referees are human, and so they can miss some of the stuff from time to time. So it wouldn't be surprising if the mean difference in points was different than just 0 just on random chance. Okay? Because I know things happen in my classroom that I don't see. I know it. It is. Like, and things happen where I can't hear it. Right? Okay? I'm human. I make mistakes. Fact. Okay? So in the study, researchers showed the video clips of 42 referees and the difference in the points rewarded. So they did red minus blue, because red was supposed to be better. That's what they were trying to see. The mean difference was 0.94 points. And I don't know if points got put on the back. Yep. So 0.94 points. And the standard deviation was 2.14 points. It appears that the referees gained about 1 additional point to the red competitors. So they want us to calculate the 95% confidence interval. So, Trey, put one up, please. Thank you. Trey has this one up too, but you put yours up. I'm still waiting for Trey to put his up. Thank you. Okay. So using the formula, you're going to have the performance, which is also the same as the mean, which was what? What was our mean? 0.94.
I can't read your handwriting. What's it say on there?
2.14 points. So 0.94 plus or minus. So because I have plus or minus, how many answers am I going to have? Two. The standard deviation, or 2, divided by, or with the division sign, what goes on top? The square root of what goes on bottom, which is, remember, n is the represents, how much? 42. N is the observation, so they had 42 referees, so n is 42. So using your calculator, calculate your confidence interval. It was the standard deviation. It was given. So in calculating, you put 0.94 plus 2, and then how to parentheses 2.14 divided by. Trey, I'm about to take your cell phone if I have to ask you to put it up again. I got 1.6.
You gonna give me attention now?
If I have to ask you to put it up again, I'm taking it. Okay. What did you get for the 1.2? With the plus or the minus?
Minus, I got 0.27.
0.27?
Nah.
Did you get the same thing, Destiny? Did you get the same thing as her, Dominique? Okay. So, this is our 95% confidence interval. So this means we are 95% confident that the interval of plausible values from 0.27 to 1.6 contains the true mean difference in ability for the competitors to earn points when wearing red and to earn points when wearing blue. Okay?
So we put the
Yes, because think of it as, if I had a number line, Destiny, what would, if you were reading it from left to right, what number would come first, 0.27 or 1.6?
0.27.
0.27, so you brought 0.27 first. So basically, this means that his true ability should fall within this confidence interval. Because all of the plausible values for the mean difference is above 0. Because all of the values are in the confidence interval are above 0, that means that because it's a positive confidence interval,
Right.
and we're planning for red to be better,
Yeah.
then does that mean more of the referees gave more points to red? Yeah? So, but wasn't the point supposed to be equal?
Yes.
So what does that mean about the refs?
They
They didn't cheat. They showed favoritism. They were biased. Okay, they were unfair. So this study proves or provides convincing evidence that referees tend to reward more points to competitors while wearing red than competitors while wearing blue. So because the order of the clips was randomized and everything in the clip was identical except for the color, it seems that the attribute of the differences points to referee was biased.